Okay, guys, we now literally have all the necessary tools we need to write a proof. And a proof sounds very sophisticated, and it's very K-level, and it's what real mathematicians do in real life. So we are going to focus for now on two-column proofs, even though there's paragraph proofs, there's flow chart proofs, and there's two-column proofs. When we're writing a two-column proof, which we've done in other units, just a reminder, we always start with a given. So we make a statement, it's given to us, and our reason is given. Then, from that statement, we start to make new statements that follow the logic, just like we did on the drawing conclusions day. When we decide what reason we have for our statements, we use our definitions, our properties, and our theorems, okay? So that's what goes in the reason column. So the statement is what we're trying to say is true. In the statement column, say something that's true about the picture. In the reason column, tell me why you know that's true. This is just a quick analogy, really fast. When you are making a peanut butter and jelly sandwich, there are certain steps that you take, right? Like, if you look at all of these steps, let's see. I think before you open the lid of the peanut butter and the jelly, you have to first take the bread, peanut butter, and jelly out of the pantry and get a knife from the silverware drawer. Like, that's what you have to start with. You can't start with eating the sandwich if the sandwich doesn't exist yet. Now, people could argue that I could change these. You spread the jelly on first, you spread the peanut butter on first. I bet you're very opinionated about that, but it does not matter. So those could be interchangeable. But then we need to put the bread together. Oh, sorry, we need to open the lid first. Don't try to spread peanut butter with the lid on. And then finally we eat the sandwich. So what I'm trying to say is that the first step and the last step are pretty much set in stone, just like a proof. You will always start with a given, and you will always end with a conclusion. You will always start with a given, and you will always end with a conclusion. But what you do in the middle sometimes can be in a different order than what other people do. Okay. So on these, you can just watch. You don't need to put this in your notes. All right, so here's an empty proof, and we're going to start by writing the given. Yes, we are. We're going to copy it. Segment RT bisects angle QRS. Why does it do that? I don't know why it does that. It's just given. Okay. I want you to not go to the next given now. I want you to see if that statement lets you conclude anything else. RT bisects QRS. Can we add a marking to our picture? That's what I want you to ask. Good. So this guy cut this angle in half. Whoa! There's a marking that we can add to the picture. Now we have to write it down. We have to document that we did that. We have to document it. Okay, so I would say that angle QRT is congruent to angle SRT. That's what arcs mean. When you add arcs to your picture, you are saying the two angles are congruent. What's the reason? Good. Remember, the reason is in the question. Look at the step before. There was a bisector. That's the only reason I added those arcs was because of the word bisector. So my reason is definition of angle bisector. Okay, we're at a dead end there. Can't do anything else with that one given. So then we move to our next given. Oh, that's nice. Angle 1 is simply congruent to angle 2. Given. Don't forget, every time you do this, when you are given information, make sure you mark it on your picture. Okay, whoa, there's 2 steps left, and there's no more givens. Our goal, what's our goal? What's our conclusion? What's our proof? We're trying to prove that he's guilty of being congruent. I don't have enough information. All I have is angle. So what do we say next? Oh my goodness. Okay, so if I were solving this on a quiz, I would add tick marks to that segment. Well, now when you do something like that, you just have to document it. What are you saying when you add tick marks to RT? You're saying that segment RT is congruent to segment RT. That's what that tick mark means. What property allows you to say that? The reflexive property of equality. Yay! There's only one space left. I know exactly what to put there because I had to start with the given and end with the proof. So I'm simply copying this here. Triangle RTQ is congruent to triangle RTS. And the reason is not proof. Just because the reason is given for the other ones, the reason is not proof. You got it. It's angle, side, angle. And you can put theorem if you want. It is a theorem. It's not just an acronym. It actually means something. So you can put theorem. Okay, let's do another one. Let's start with the given. Given segment AE bisects segment BD. Whoa, we were given, that was one of the things on last night's homework. Okay, what's the reason? Given. Now let's go mark our picture. Well, good, good. What can we add to our picture? Now BD was the one that got bisected. She's the victim here. Okay, so we add tick marks to our picture. When you add a marking, you must write it down. Segment BC is congruent to segment DC. Definition of, very good. Segment, you must put segment. It's not just the definition of bisector, it's definition of segment bisector. Alright, we're at a dead end there. We've used this given. You're done. We used you. Okay, what's our next given? AC is congruent to EC. Oh, that's nice. So I guess the other one was bisected as well. That's cool. Given. I don't know why there's so much space between 3 and 4. What do y'all want to say next? Okay, so the next thing I would mark if I were solving this on a quiz is I would add arcs there. And so now I have to document that. I added arcs. What do those arcs even mean? They mean angle 1 is congruent to angle 2. And why are we allowed to say that? Vertical angle theorem. And I always know what goes in the last step. I always know it's to prove. ABC is congruent to EBC by the side angle side congruence theorem.